Assalamualaikum warahmatullahi wabarakatuh. Very good evening to everyone. Thank you for coming in. Um, so, as you all know that basically we have our weekly classes on every Monday at 8 p.m. until probably 9:30 or so. At the moment, there will be no classes on Wednesday up until where we already start our um, half of the semester. Then, if required, then I will add on classes on Wednesday. But at the moment, we will stick only on Monday at 8 p.m. Okay? Is that okay, everyone?
Yes, better.
All right, cool.
Yep.
Yes, any question? Okay, good. Tak ada question bagus.
No.
Yeah.
No,
Yeah.
tak ada question.
Yeah. Tak ada question, eh? Okay. Okay, as you all know that I've already uploaded the notes in e-learning. So you can always refer to e-learning where I upload all the slides before the classes, insyaAllah. But at times, kadang-kadang, if my schedule is too tight, probably I will upload the slide after the class also. But I will try my best to upload before the class so you can download the slide lah. So let's go through today's session. Let me just share my screen. Can you all hear me clearly?
Yes,
Doctor.
Yeah, okay, good. Just making sure that my voice is clear. Okay, can you see the slide?
Yes, Doctor.
Yes.
Okay, all right, good. So let's start on today's session. Okay, as you all know, okay, I haven't checked yet your homework from last week, but I'll definitely I'll check after this class. But by then, you should be able. By now, when you did your homework that I gave you last week, you should have some understanding on how relevant or not relevant of internal combustion engine in today's world at the moment. But definitely, I think um, uh, um, uh, we will discuss further later about that topic. Okay, so news this week. This is what I got a few days ago. BMW declared that they won't stop developing internal combustion engines. This is basically immediately after Audi stated that they are stopping their engine development. Whereas on the other hand, BMW CEO said we are not done with internal combustion engines. But nevertheless, that doesn't mean that they are totally focusing on internal combustion engine. Okay. They are aware that eventually we will definitely go for electrification. But as for now, in the coming recent years, BMW state that they won't stop developing internal combustion engine. So if you have time, you can just go through some of their websites. They are still developing gasoline and also diesel engines. And at the moment, concurrently, they are also working on hybrid and electric vehicles as well. Okay, so well, this is what they stated. Okay, public. So that is a statement from BMW. So this week I've already started. This is a probably 1 minute session that we will try to continue on every week. I've already started this week's punya news, but next week I will hand over to each of you to share just before we start our class. Probably one of you can just show a clip, one page slide on probably five of you at least, just to share what's the news going on related to internal combustion engines in the news. You can pick in any internet punya articles or manufacturer punya articles and so forth, just to share with everyone. Nothing much, just to share a clip. Probably just a very brief explanation, about 20 seconds, then we can move on to other students. So just before that, let's just choose next week punya session. Okay. I'll choose 5 students first. Okay. So next week, Daniel, can you start first? Daniel Firdaus.
Okay, Doktor. Boleh.
Muaz, mana Muaz? Next week, Tanes, mana Tanes? Where are you, Tanes?
I am here, Doctor.
Okay. You 2, 3. Irfan. Oh,
Ya,
Irfan.
Doktor, ada.
Okay, Irfan. And so Farhana, Farhana, are you there?
Okay, Doctor.
So nothing much, just to share a clip saja, one page, very quickly, dalam 15 to 20 seconds je, just to share just a highlights of whatever news you got lah. But related to internal combustion engine, does it really matter whether is it if it's a positive news or negative news? Does it really matter? Just for fun lah. Okay, let's continue back to our topic for today. So next week will be Daniel, Muaz, Tanes, Farhana, and also Irfan. Okay, 5 of you. Then the following week we choose another 5. Can you all see my slide?
Yes, Doctor.
Okay, let's start on chapter 1. First of all, we need to understand what is classifications of engine. Okay, this is how you classify engines in from engineering perspective lah. Okay, so just before that, we will just go through very briefly on the history of internal combustion engine. In fact, actually, this note is quite an old note. I did this slide on 2017, which is why you have that arrow of showing you are here 2017. But more or less, internal combustion engine actually started roughly about 248 years ago. It was originally started in 1973, whereby Huygens and Hollands developed a concept, on paper. But then in 1760, this is when Watt and Britain actually discovered a steam engine in 1766. This was actually the first combustion engine. Okay. And then if you could see above year 1860, you can see there's a quite multiple developments being achieved up until 20th century. You have the 4-cycle Otto by Mr. Otto, of course. You have the Daimler and also Dutch on gasoline engine. And then you have the passenger usage of gasoline and also diesel engine in America in 1900. And then 1903, you have the Wright brothers flying the first airplane using gasoline engine. And of course, as you all know, that the first mass production vehicle engines by Mr. Henry Ford by the model, what they call as T model lah. And then the rest, you can see the multiple, of course, there's many inventions that was done after the T model up until today. So, in essence, internal combustion engine is quite an old technology. Okay. So, if you refer back to the first mass production vehicle, which is T model from Ford, it's quite old. It was first produced in 1909. Okay. You can also see of how the internal combustion engine of the T model is quite a vintage design, but yet they have already started the four-cylinder engine. Okay, you can see that. But then now, in 112 years later, from the T model, this is roughly in 2021, basically the advance of technologies has significantly improved with all the technologies being incorporated nowadays. Not just on the technologies itself, this is also include in terms of the materials, the processes, the equipments, and so forth. So all these technologies has been used, it has been used and consolidated to produce a quite modern advanced engines we have today. Okay. So basically, if you talk about heat engines, it can be categorized into two, which is in general, heat engines can be categorized into internal combustion engines, which is why you have the IC engines. Or in other words, the word explains itself, which is combustion that takes place inside the engine. Okay. Hence, you have the internal combustion engine. Okay. And then you have, of course, you have the external combustion engines where combustion takes place outside the engine. But before that, we need to understand that engines, by definition, is a device which transforms one form of energy into another form of energy. This is what the main definition of engine. But in related to heat engines, yes, it transforms the chemical energy into a thermal energy. Okay, and utilize that thermal energy into mechanical energy and so forth. So unfortunately, we are not covering the external combustion engine. Okay, we are only covering the internal combustion engine, which is why we have this course to be named as internal combustion engine lah. And in under internal combustion engines, of course, you have the two types of configuration, which is the rotary and also reciprocating. Unfortunately, we won't cover rotary. Okay, unfortunately, okay, we will only covering reciprocating, and under reciprocating, we will only cover on gasoline and diesel engine only. Okay, unfortunately, but yeah, there's a lot for us to cover within this 14 to 15 weeks. Mainly discussing, mainly in the context of gasoline and diesel engine. Okay. So far, any questions? And if you're talking about steam engines, Stirling engines, gas turbine, those are all actually under external combustion engines. So we are not covering steam, Stirling, and also closed cycle gas turbine lah. So if you ask what is the focus under heat engines, yes, we are only focusing on gasoline and diesel for this course, unfortunately. Yep. Are you all okay with this?
Yes, Doctor.
Yes,
Alright.
sir.
Okay, cool. Okay, next. What is the advantages of internal ICE over external combustion engines? So, internal combustion engines are, well, mechanically simplicity and improve efficiency due to the absence of heat exchange in the passive way of the working fluid. This is involving boilers, condensers in a steam turbine plant. This is basically, if you have an external combustion engine, it's very complex compared to ICE. ICE is everything is quite simplified compared to external. And of course, ICE has a higher thermal efficiency. This is because the components are actually work in an average temperature below the maximum temperature of the working fluid in the cycle. Okay? And you are not looking at extreme temperatures, you're looking at average temperatures, and therefore possibility of developing smaller power output engines to fit for the necessary applications such as road transports, vehicles, motorcycles, and so forth. Okay, so that is just a brief on internal advantages of ICE. Okay. Um, Nevertheless, there's also this disadvantages of ICE. ICE is well known for its vibration. Okay, especially if you have if you don't have the correct number of cylinders. Uh, okay, and only liquid or gaseous fuels are given specification is applicable, which are relatively more expensive. Okay, in other words, compared to like steam engines or Stirling engines, their fuels are much more cheaper lah compared to the fuels we're using on internal combustion engines. So let's go through the engine classifications. So ICE can be built in many different classifications. Okay, for a given engine, using either 4-stroke or 2-stroke, okay, or diesel cycle. The classifications of any most of the engines at the moment, you're looking at mainstream engines, mainstream production engines. You can classify those engines into 5 categories. Okay, first is the piston cylinder geometry. Okay, next is the valve arrangement. Third is the fuel delivery system. And then we have the cooling system, and of course we have the air intake system. Okay, so those are the 5 classifications of that falls under engine. So in terms of the first one, which is the piston cylinder geometry, okay, you can classify the piston cylinder geometry on internal combustion engines into variation of configurations. You have the single engine, you have the V-twin engines, you have the triple engines, or in other words, you have the 3-cylinder engine, and then you have the 4-cylinder engine, you have the 5-cylinder engines, you have the V5, you have the V6, you have the V8. Of course, you have the V10 over here, but it's quite popular. V10, V12. Boxer twin, flat 4 is the most famous ones in Subarus, in Volkswagens, in Porsche. Of course, you have the flat 6, which hardly we can see nowadays. Okay, talking about flat 4 are the most preferred nowadays by manufacturers. Or in other words, they are also called flat engines as boxer engines as well. Of course, and this configuration, the choice of a given arrangement depends on several factors and constraints, such as engine balancing and available volume. So, in order for a manufacturer to decide which engine piston cylinder geometry they should use, it depends on the application, and so of course several other considerations, such as whether if the vehicle is actually a small car or a sports car and so forth. So they need to consider many factors, but also they also need to consider other factors as well, such as the how severe is the vibration of the engine. Okay, as you all know, three-cylinder engines are the worst engine in terms of vibration, which is why if you drive a three-cylinder engines, you can see you can feel the vibration. This is because the harmonic balancing between the three cylinders. The most balanced engine. Can anyone guess?
W engines.
Sorry, come again.
Boxer engine or V6 engine.
Inline 6.
The most balanced is actually the number 6, either in an inline or V6. Okay. So you can look further why inline 6 and V6 are the most balanced engine. Okay. The worst is 3-cylinder lah. Okay. If you were planning to buy Pro 2 Ativa, it's a 3-cylinder turbo. Okay. You can feel the vibration and so forth. Which is why when they design 3-cylinder engines, if you notice that they have a special balancer on the cylinder block, just to absorb the vibration of the vibration from the caused by the 3-cylinder. That balancer shaft is not available in 4-cylinder, 5-cylinder, or 6-cylinder. Most of the time, only 3 cylinders will use that balancer shaft. Okay, you can look through further in the internet and learn further from articles and so forth. So the inline engine is the most popular as it is the simplest to manufacture and maintain. Of course, if you are a manufacturer, you don't have lots of money, just produce a inline engine, as simple as that. Okay, just imagine if you produce a V6 engine. If you produce a V6 engine, that means you will need 4 camshafts. Okay, 48 units of valves. Okay, so the cost is getting higher. Okay, so inline is the most cost efficient, even if you compare with a boxer or flat engine. Okay. Now, reciprocating motion of the containing rod and piston creates initial force and movements that need to be considered in the choice of an engine configuration. Of course. Okay. So next is the valve arrangement. Okay, moving on after the piston cylinder geometry is the valve arrangement. So gases are emitted is what we call as the intake gas. Okay, and expelled as what we know as exhaust gas from the cylinders by valves that are open and closed, or by ports that are uncovered or covered by the piston. Okay, if you are familiar with automotive engines, most of the automotive engines are the entry and also the expel of the gases into the combustion chamber is actually controlled by poppet valves. Okay, poppet valves. But those who plays motorcycles, especially mopeds, so forth, if you're looking at two-stroke engines, you don't have valves. Instead, you have ports that are covered and also uncovered by the movement of the piston. This is quite familiar for those who is familiar with two-stroke engines. Yeah, probably you are well aware of this. So that is the main purpose of having valve. Okay, so poppet valves are the most popular and common ways of controlling the gases. It is the primary valve type used in internal combustion engine nowadays, since they have excellent sealing characteristics. Okay, you can see that you can see that how that picture over there, the movement of the valves is actually controlled by the movement of the mechanism, which is from the camshaft, springs, and so forth. So, and next, of course, nowadays with the engine technology, nowadays you have electrical actuators, electronic actuators, and so forth, or motorized to control the poppet valves opening and closing. So, but I would say 90% or probably 90 to 95% of automotive of internal combustion engine in road transport nowadays are actually using mechanical actuators. Okay. One of the I would say if you want to know which one is using electronic actuators is if I'm not mistaken, is the latest Fiat 500. Okay. But of course, there's a few road cars nowadays are using electronic actuators. Okay. So currently, most engines are using valves located in the cylinder head, which is an overhead or eye head configuration, as this is the configuration that has good inlet and also exhaust flow characteristics. This is a quite and most of the internal combustion engine is using this configuration of whereby the whole mechanism of the valve train is actually of the on top of the combustion chamber. Those days, if looking at probably 30 to 40 years ago, the only thing that the mechanism that controls the inlet and also the exhaust valve is basically consists of camshafts, which is located in the cylinder block, which is underneath or at the bottom part of the engine and so forth. So they have like a quite complex configuration. But nowadays, most of the valve trains mechanism is all located on top of the engine in the cylinder head. This is why some of you, most of you are already well aware of the word Dodge, 16 valve and so forth. But I hope this you can actually understand what is Dodge and 16 valve by now, lah. Okay. So the Dodge is basically stands for double overhead camshaft. Okay. Well, basically it's the number of valves in the engine. Okay. So it means 4 valves per cylinder for a 4-cylinder engine. So a camshaft is actually rotates at half the engine speed for 4-stroke engine and controls the valve timing. So always remember that the camshaft always rotate half of the whatever the crankshaft is rotating. Okay, when we refer to the engine speed, or in other words, the RPM, okay, that is actually the rotational speed of the crankshaft, not the camshaft. Is the rotational speed or RPM of the crankshaft. Okay, so loops on the camshafts along with filters, push rods, and rocker arms control the valve motion. So that is basically the main mechanism of the valve train. Okay. Some of the main important components such as the cam and cam loops, camshafts, we have the bucket types, sort of mechanical actuators, and of course you have the valve springs, valves, and camshaft sprockets is basically the camshaft or the pulley that is being connected to the camshaft. Okay, and the camshaft pulley or camshaft sprocket is actually driven by a belt or a timing chain, and that is actually driven by the crankshaft. Okay, of course you have the idle wheel tensioner for the belt, but nowadays if you have a timing chain, you don't have an idle wheel anymore. So as technology advances, most of the engines, I would say half of the internal combustion engine nowadays are using timing chain. Okay. The valve timing. Okay, this is something that most of the engine has, which is as you all know, the variable valve timing is a common technology which is currently being used in most engines. So the purpose of the VVT, variable valve timing, is basically to variate your valve timing according to the engine speed. This is basically to manipulate the intake and also the exhaust gas flow that goes into the combustion chamber and goes out to the combustion chamber. If you don't have a VVT, or if you don't have a variable valve timing, so whatever the gases that goes in and outside, it will be in a fixed timing. Okay, hence, which is why they introduce a technology what they call as VVT lah. Okay, so the valve timing can be varied. Okay, why do you want to why you want to vary the valve timing is basically to increase the volumetric efficiency using advanced camshafts that have movable loops or with electric valves and so forth. So with a change in the load, okay, in other words, if your engine is producing different types of power output, the valve opening duration and timing can be adjusted so that it can supply the correct amount of air and also to expel the correct amount of air outside the combustion chamber. So this needs to be synchronized, okay? So in other words, the valve timing needs to be changed accordingly to different engine speed and also different engine load. Okay. So if you plot the synchronization of between the exhaust and also the intake valves opening with respect to the position of the piston, this is how you would map the activities and also the events of the exhaust valve. So you don't need to understand this one yet, but this is just to show you, okay, how you can actually describe or actually you can actually characterize of how the exhaust valve open and how does the intake valve open in a one complete cycle. Okay. So we will go through this in our later chapter, but this is just to expose you. This is something that which is quite important in order to understand or how to have a certain characteristics or for the valve opening in order to have a higher volumetric efficiency. Okay. So let's go through the air intake system. Of course, you have the natural aspirated, then you have the forced induction. So I think some of you are quite well aware of this. You you have the natural aspirated air intake system and the forced induction. The differences between natural aspirated and also forced induction or natural aspirated, or what they call as NA engines. The air that goes in is basically so NA engines are basically used in most automobile engines, because why? Because it doesn't require a lot of components compared to the forced induction. Air and fuel mixtures are sucked into the cylinder by vacuum caused by the cylinder movement, volume expansion. So in other words, it is basically naturally because of the movement of the pistons, okay, from the top dead center to traveling down to the bottom dead center. Because of that movement, it creates a void or a volume, and because there's a volume, because of that volume, it creates a vacuum. And because of that vacuum, the air actually is being sucked into the combustion chamber to fill in the gap, the void lah. Okay, so NA engines generally use less power than forced induction of the same displacement. You can't actually compare 1.6 liter NA engines with 1.6 liter forced induction engines. That is unfair. Okay, NA engines produce lower power compared to the forced induction engines, but the fact that development of NA engines tend to be much way cheaper compared to forced induction engines. Okay, so for a manufacturer to produce NA engines is not that challenging, but for them to produce a turbocharged engines, it's quite challenging. Okay, but yeah, but as you all know that most of the passenger cars nowadays, in Malaysia, don't look outside Malaysia. Just look in Malaysia at the moment. Most of the passenger cars are turning into turbocharged engine. With Proton, with Pro Duo, Honda, Nissan, with the new Nissan Almera, also is a turbocharged engine. But under the forced induction engines, there's two categories, which is the supercharger and also the turbocharger. Most of the time, people would like to use the turbocharger because of the wasted energy benefit compared to a supercharger. Okay, so on a supercharger, basically it is mechanically compresses the inlet air to a pressure higher than the standard atmosphere by a compressor powered by the crankshaft. So in other words, you can see that on a supercharger there's always a pulley which is driven by the crankshaft. And this pulley is actually connected to a turbine or a spiral compressor inside the supercharger, which compresses the air. Okay, and that compressed air is being fed or being forced into the combustion chamber, and hence you have a pressurized pressure into the combustion chamber. Some of the superchargers are being driven by the crankshaft by a belt. Some are being driven by a mechanical gears. Depends. Okay. So the compressor raises the density of the incoming charge so that more air can be delivered, okay, into the cylinder to produce higher power. Okay. So in other words, it compresses the air and pushes or forces the air into a higher density to go into the combustion chamber. If in the fact that when you have a higher pressure or higher density of air, inside the combustion chamber, definitely you will produce more power. Okay, unlike the NA engines, right? Unlike the NA engines, everything is being forced. Hence the word forced induction. Okay. Now, for the turbocharger, it's using the same concept. Yes, it's elevating the pressure to a higher pressure, increases the air density, but not by using mechanical, but it's not using a mechanical driven. Instead, it's using the exhaust gas energy to propel a turbine. Okay, to propel the turbine, and that turbine is actually connected by a shaft that to a compressor, and that compressor actually compresses the air to go into the combustion chamber. So instead of using a pulley like the supercharger, no, it's not using a pulley. It's using the exhaust gas energy to propel the turbine. That turbine is actually connected to a compressor by a fixed shaft. Okay, so that is a turbocharger. So in turbocharger, exhaust gas leaving an engine is further expanded through a turbine, which drives a compressor to increase inlet air pressure higher than standard atmosphere. Okay? And then when you compress the air, you improve the engine power density, and of course, you with higher pressure inside the combustion chamber, you will definitely produce a more power, higher power. And yes, I think most of the internal combustion engines running on gasoline is going towards the turbocharged because it's more, the power density is much higher compared to the natural aspirated. And of course, for diesel engine, almost 100% of all diesel engines are running on turbocharger. Okay. So yes,
Between supercharger and turbocharger, which one is better in terms of power production?
right. Okay. It depends on the usage. Okay. If I would like to ask, I would like to answer that in terms of from engineering punya perspective lah. Then I can ask from I can answer that from manufacturer punya perspective. From engineering perspective, definitely turbocharger will definitely produce more power because it is you are actually using the exhaust gas energy, okay, to propel the turbine. And if you ask me, in terms of internal combustion engine, 40%, okay, 40% of energy is actually if you have a 40% of the energy is being wasted to the 40% is being wasted to the exhaust side. So if you use that 40% of energy to power the turbocharge, that you can actually produce more power. So in other words, you are actually using the wasted energy. But on the supercharger, instead of using the wasted energy, you are actually using the energy that is being produced by the engine. So in other words, you're using the energy from the crankshaft, which is that energy from the crankshaft supposed to go to your wheels, but instead you are taxing or you taking a bit of that energy and using it back to the supercharger to compress the air. Whereas on the supercharger, okay, that exhaust energy is supposed to be wasted, and that actually doesn't actually affect of how much the initial energy is being produced in the combustion chamber. So that is basically uh, from engineering punya perspective lah. Definitely, of course, on a turbocharger, it is more efficient. You will definitely produce more power with using the wasted energy. Okay. Okay, tak?
Okay. But why people still use supercharger instead of turbocharger?
Okay. Correct, because okay, if you look through the application of superchargers ni is mostly on America. America ni, they have any Americans here? There's no American here. Any of you Americans? No. Okay, Americans they like to do their own way lah. I think they like instead of playing soccer, they play football. Uh, uh, People play with turbocharger, they play with supercharger lah. So they have preference on supercharger. Definitely, benefit of supercharger ni, the response time is very very faster compared to turbocharger. Because supercharger ni is being driven by your crankshaft, so you can actually activate the supercharger at a lower engine speed compared to a supercharger. On superchargers, you're looking at between nowadays, those days lah, turbochargers are able to work efficiently above 3000 RPM. But nowadays, I think with the correct engine design, you can actually have the turbocharger working as low as 1000 RPM with the latest technologies nowadays. And of course, with the latest engine designs, modern engine design, and so forth. Superchargers, they are, because the fact they are actually driven by the belt and by the crankshaft, so you can actually activate. You can have the supercharger working at any lower engine speeds, so it doesn't really matter. But why does some, I would say few lah, not all, few manufacturers, they prefer to go for superchargers is because personal preference, and because the fact that they have quite vast experience on supercharger, so they don't tend to go to turbocharger, which is why most of the American cars, specifically on American muscle cars and so forth, they it's because of tradisi, the traditional way of having a force induction using supercharger. But in terms of efficiency, definitely nowadays with the latest technology, you cannot beat turbocharger. Okay. Okay.
Okay.
It goes the same juga if you ask me why Mazda keluarkan rotary. Can anyone answer why they keluarkan rotary? Why they love rotary so much?
Tradition, I guess.
Yeah, it's tradition. It's because they like it. They love rotary so much. So manufacturers, they do sometimes it's because of the tradition, or that is what make them unique lah. So if they believe in, for example, Subaru, why they believe in boxer engines? Well, the fact that Toyota, Mercedes, and BM, they are producing more higher efficient engine nowadays with the inline configurations, but yet Subaru still believe in boxer engines. But I think nowadays with the latest movement of going electrification, I think Subaru also going for electrification. So probably there's no more boxer engine after this. Yeah. As rotary engines, we're looking at from the Mazda RX-8, I think the Nemesis, that would be the last. Based on today lah, I don't know whether they are producing more rotary engines after this with the move. Well, with all the manufacturers are actually looking forward to produce electric engines. Not sure whether Mazda is actually is planning to have a rotary engine in their future production. But we'll see. Okay, if you can keep us updated lah if you have any news on that. Okay, let's move on to the fuel delivery system. Of course, there's two types of delivery system. Simple, it's the port fuel injection, which is the normal engines. I think I would say it's a quite old technology. It's being developed by Bosch, but nowadays most of the engines are running on direct injection or GDI. Most of the Hondas are actually running on GDI already. Mazda, I think 10 years ago, all their lineups are running on GDI already with all the Sky Active technologies and so forth. Not sure on the Pro2 Ativa, whether is it running on GDI or not. Probably you can. But yeah, everyone is moving towards GDI. Okay. Why? Because definitely by theory, if you have a gasoline direct injection, if you compare back to back between PFI and also GDI, GDI has a better fuel consumption by at least 25%, at least 25% of the same spec, okay, with the same configurations, same specification. If you have two different fuel delivery system between PFI and GDI is much more more economical by the at least 25%. So yes, GDI is there. Next one, what's the difference between PFI and also GDI? Senang je, it's very easy. PFI quite straightforward. The fuel is being injected on PFI or in port fuel injection. Fuel is actually being injected before the intake valves. Before the intake valves. Okay. It can be located in the cylinder head, in the intake port. It can be located in the intake manifold. But as long as it is not being injected in the combustion chamber, it is considered as port fuel injection. As simple as that. Okay. Whereas on the GDI, very easy. All the fuel is being injected directly in the combustion chamber. Okay. So on the PFI, PFI are in the intake ports of each cylinder, just upstream of the intake valve, or in other words, before the intake valve. Okay. So there's an injector for each cylinder. PFI does not need to maintain a continuous fuel spray since the time lag for the fuel delivery is much less than of a throttle body injector and so forth. Okay. Whereas with the direct injection, the fuel is sprayed directly into the cylinder, into the combustion chamber during the late stage of the compression stroke. So with GDI, you can actually, because the fact that the injector is in the combustion chamber, you can actually control in detail when you want to inject and how much do you want to inject compared to PFI. Because of the PFI, the injector is actually located before the intake valve. It will take time for the fuel to travel, and some of the fuel might be evaporated and might be stuck in between the valves and so forth. So there's many issues and so forth. But compared to direct injection, where you have the injector directly pointing into the combustion chamber, you can actually manipulate when and how much you want to inject the fuel precisely. Which is why you can have a fuel consumption benefit by at least 25%. Of course, those who likes Waisuku and Waisuku pun that actually water cool. PS5 good. Air cooling, and this is very old technology. Yeah, if you drive a Volkswagen Beetle, the old Beetle, it's being cooled by air lah. Yeah. So how to know whether it's air cool or not? It's because you can just identify by the design of the fins on the cylinder block and also cylinder head. Another configuration is basically cooling systems. Okay, and, liquid cool. You have besides the air cool, you have the liquid cool lah. Liquid cool, you need to have the coolant to extract the heat in the cylinder head and also the combustion chamber, and bring that heat or move that heat away from the engine, and because of the heat transfer, and the heat is actually being transferred through the radiator. Yeah, this is when the heat is being exchanged to the air that passes through the fin in the radiator. Yeah. So let me ask you one question. Okay, which part of the engine is the hottest?
Exhaust.
Lagi?
Exhaust manifold.
Lagi? Any more questions? Any more
If I'm not
answers?
mistaken, catalytic converter.
Okay.
At one point of time ke ataupun continuous?
Both also can.
Combustion chamber.
Okay. I think all of you correct. If you're looking at different perspectives, like overall, I think if you looking at like Daniel check today, if you're looking at one moment of time, okay, highest temperature will be on top of the piston, which is the piston crown. You're looking at between 1000 to 1008 degrees Celsius. Okay, but it fluctuates the temperature because of the movement of the piston and the cooling that passes through the cylinder head, cylinder block, and so forth. Yes, exhaust manifold would be the highest, and catalytic converter also the highest. Exhaust manifold, looking at between production engines, you're looking at between 900 to 1000 degree at maximum power. Okay. Ceramic in the catalytic converter also, it will definitely melt. It will melt at 1200 degrees Celsius. So most of the time, manufacturers will try to have that engine to operate below 1000 degree lah. But continuously it cannot run above 1000 degree. If you're looking at the exhaust manifold, exhaust valve also can only last up until 1200 degree. And I think most of the parts will definitely like the ones with even with the exhaust valve with sodium field that can only stand up until 1002 to 1000, roughly about 1002 degrees Celsius. Uh, Exhaust manifold will definitely crack or melt at 1002 degrees. Ceramic in the catalytic converter also will definitely will crumble at 1200 degrees. So looking at those are some of the most hottest component. Another question: between cylinder head and cylinder head and cylinder block, which one is the hottest? Which one is hotter? Cylinder head or cylinder block?
Um, It
Why do you say cylinder head?
because the cylinder block, you got the water channel, the cooling channel that cools the block itself.
Hmm. Okay, cylinder head, yes, is the hottest. That's because kalau you tengok the cross section of the combustion chamber is actually in the cylinder head. Combustion chamber only less than 10% is in the cylinder block. 90% of the combustion chamber is in the cylinder head. So most of the heat from the combustion is actually transferred to the cylinder head. Now, knowing the fact that is that okay? Why cylinder head is the hottest?
Yeah, that time. Yeah.
Which is why now you know where is the hottest. Now you can actually design where does your cooling system should go. Betul tak?
Yes.
Yes. Which is why nowadays the latest engines nowadays they also have cooling system. Most of the time, coolant will go into the cylinder head first, and then it will go to other components such as cylinder block and so forth. But the latest engine, modern engine nowadays, some of the cooling channels also goes to the exhaust manifold, to the exhaust system, so forth. Just to bring down the temperature. Okay. So that is basically roughly about cooling system lah, I think. Okay. Okay, just before that, I would like to give you more homework. Okay. Just homework for you to explore. So explore the upcoming ICE key technologies based on the 5 engine classifications, which is the piston cylinder geometry, you have the valve arrangement, and then you have the cooling system, you have the fuel delivery system, you have the air intake system. So those based on that 5 configurations, okay. Turn your findings into a creative, attractive poster with the title of Future of Internal Combustion Engine. Notes do in a group, okay, between 4 to 5 members. Submit a soft copy in a JPEG, bitmap, also PDF format. Because apparently I want to have this published. I want to put this one in my room sebenarnya. So deadline 4th April 2021. Okay, no need to print, just design a very good poster. Just choose, just to highlight, to address. If you like to more on the technology on V10 engine, then be my guest to explore more on the V10 engines. But you need to touch the 5 classifications, which is what is the 5 classification? Piston cylinder geometry, what is the key technologies nowadays or the upcoming one? Valve arrangement, what is the latest technology on this? What is the upcoming technology on this? Fuel delivery system, is there any upcoming fuel delivery system beside the GDI? Okay. Is there any technology in the GDI itself? Okay. Probably the injector itself and so forth. Cooling system, probably, if there's any upcoming technologies, they don't use cooler anymore, probably. They use pump oil, probably. I don't know. Intake system, is there anything other than force induction? Is there the other thing than supercharger? Is there other thing than turbocharger? So you don't need to highlight everything. Just choose one technology in your poster for you to address in that technology under these 5 classifications. Okay. Contohnya, piston cylinder geometry. What is the upcoming technology? Probably based on you punya finding, you cakap, oh, the next one is the opposed cylinder engine. Pernah dengar tak the opposed cylinder engine?
Tak pernah.
Opposed cylinder ni is like the opposite of boxer, whereby jantan bertemu jantan, tahu tak? So it's like
Piston head with piston head.
yes. So they will instead, if you look at the flat engines, okay, it is on the opposite way. So in other words, the crankshaft is actually on the flat engines. You have one single crankshaft in the middle, but on a opposed engine is actually you have 2 crankshafts on the outside, and the pistons is actually meeting each other. So, but just to share lah. So you just choose your own group members. Work with kalau boleh groups of 5. Kalau boleh groups of 5. Create one poster cantik punya. Okay. And I will definitely, once I get all at least 5 to 6 posters from you, I will definitely print and tayangkan dekat faculty lah. Okay tak?
Okay.
Alright. Okay. Use your creativity on this one. Make it nice. Okay. Also put your names on the poster lah. Yeah. Your SAM, your batch, and so forth. The title of the poster should be Future of Internal Combustion Engine. Put your names, put your batch number, and so forth. Okay. Okay. It's 9 o'clock. Can we break for 10 minutes? Then we'll continue back.
All right.
In the we'll back. Now it's 9, so we'll start back at 9:10 sharp. Okay. Can you all hear me?
Yes,
Doctor.
Yes. Yeah, let's move on to next topic. So basically, we've completed chapter 1. That's just an introduction on the internal combustion engine related to classification of engines. So moving on to chapter 2, we like to understand about the components. Then definitely we will move on to engine cycles. So hence we would be able to complete the engine cycles this week. So I'll start on the engine components first under chapter 2, and probably we can move on to engine cycles next week. So engine components, of course, there are lots of engine components. You're looking at more than 300 components on a typical engine. But we won't cover all. Under this chapter, we will only highlight some of the main components so that you have some awareness on what are the components which are important in the later chapters lah. Okay. So, of course, under the main engine components, among the main ones are basically you have the cylinder head assembly. Okay, so cylinder head assembly, in other words, it holds all the valve train mechanisms consisting of intake valves, exhaust valves, valve springs, camshafts, and also cylinder head is actually a structure for the to hold the combustion chamber, intake ports, exhaust ports, and also cooling channels. Okay, so some of the you can see a breakdown of the cylinder head assembly. It consists of many components. This is a very, I would say, a very common, typical cylinder head assembly. You have the camshafts, cam pulleys, and so forth. So it's very detailed on this one, but of course, it's just a typical one. Okay. So some of the sub-components you're looking at under cylinder head, of course, you have the valves, okay, consisting of intakes and also exhaust valves. You have the valve springs and also the retainers, okay, to hold the springs. We have the camshafts, okay. Most of the engine nowadays, we have the intake and also exhaust camshafts. We have the valve guides, okay, to hold the valves in place, okay. You have the rocker arms, okay. This is actually the part of the mechanism for the cam loop to push the exhaust to push the valves, okay. And then you have the cam pulleys, which actually has which turns the camshaft and also connect movement of the camshaft with the crankshaft. Okay, so we have the cam pulleys, okay, and of course, if you have a variable valve timing or VVT, then it is actually replaces the is also attached on the cam pulley so that it can actually manipulate the timing of the turning of the camshafts. Okay, and of course, in the cylinder it holds the spark plugs, and of course you have the coolant temperature sensors and so forth. And of course, there's many other components which cylinder head actually holds. Okay, hence why they call it cylinder head assembly. It is assembled of many subcomponents. Okay. So besides the cylinder head, we have the cylinder block. And cylinder block assembly basically it holds the piston, other components such as the pistons, connecting rods, crankshafts, crank pulleys, and so forth. Okay. So you can see that some of the typical configuration in cylinder block assembly, it holds the piston and connecting rod assembly, not the camshaft. This is basically an old technology. Camshaft nowadays is all in the cylinder head. You have the crankshafts, yes. You have the oil pump, yes. You have the timing chain, provided it's a timing chain punya engine. Okay, and you have the main bearings and so forth. Okay. Some of the sub-components of cylinder block assembly, we have the piston assembly. Okay, piston assemblies consists of the piston itself, piston ring, gudgeon pin, connecting rods, and so forth. Okay, yes, connecting rod, crankshafts. You have the oil sump, water pump, oil pump, flywheel, crank pulleys, ancillaries such as alternator, starter motor, and so forth. Okay, etc., etc. So those are some of the sub-components of a cylinder block assembly. So of course, besides that, you also have the air intake system, okay, exhaust system, and also the fuel system. So under the air intake system, you have the air snorkel, air ducts, air box, and air filter, throttle body, intake manifold, compressor, supercharge, airflow sensor, manifold pressure sensor, air temperature and sensor, and so forth. So what I need you to do is basically just to explore the air intake system, get to know the subcomponents. Of course, just browse through the internet. What is the air snorkel? What is air ducts? Okay, this one quite straightforward. The air filter in the airbox itself, throttle body, intake manifold, a compressor or supercharger, the airflow sensor, manifold pressure sensor, air temperature sensor, and so forth. So just if you have time, do spend some time to explore these components just to understand. Okay, and then you have the exhaust system. Part of the exhaust system, you have the exhaust mufflers, catalytic converter, exhaust manifold. Later, I'll get back to you why I put a question mark on that. Exhaust manifold, a turbine, exhaust pipes and bellows, oxygen sensors. Some engines has EGR, exhaust gas recirculation system, etc., etc. lah, or exhaust system. So, question. Okay. Nowadays, they have eliminated exhaust manifold. True or false? Anyone can guess?
You mean in your ICE?
Yes. Kalau electric vehicle tak ada exhaust manifold. In the ICE, yes. Most of the engines nowadays, they have eliminated exhaust manifold. True or false?
False.
False. Why do you say false? Do you still require exhaust manifold for internal combustion engine?
The manifold is the one that a series of tubes, right? It's a series of tubes combined to one.
Yeah, correct.
Okay.
Do you need that?
I think we do because we need to optimize
think we do.
the airflow of the exhaust.
Yes. Well, the purpose, yes. The purpose, yes. Just to answer your question, just to answer my question tadi, basically the concept of having exhaust manifold is basically you are right. You basically joining all the exhaust gases from each of the cylinders into a uni channel, so that you can direct that exhaust gas towards the end of the car, or you can direct that exhaust gas into a turbocharger of a turbine. Yes, but nowadays, for your information, they've already eliminated exhaust manifold. So in other words, instead of having exhaust manifold, they have designed that channel, or what you see as tube just now, into the cylinder head. You can see, if you have a chance to go into Honda engines nowadays, there's no more exhaust manifold. There's only one channel that goes outside, that goes out from the cylinder head. So in other words, they have already combined that channel of exhaust gas in the cylinder head and exits the cylinder head in a single channel. So this is what they call as IEM, integrated exhaust manifold. This is the latest ones lah. I think most of the cars nowadays. So in other words, why do they need to do that? Basically, you don't have they reduce costs. You don't need to have exhaust manifold. It still still serve the same purpose, but instead of having that joining of the channels outside the exhaust, outside the cylinder head, now it is inside the cylinder head. Yeah, hence the word IEM, integrated exhaust manifold. So that is basically the latest technology nowadays, but you can dig further on that. Okay. Of course, on fuel system nowadays, we have the fuel tank components under the fuel system. We have the fuel tank, we have the fuel lines, or sometimes they call it plumbings. You have the fuel filter, fuel pumps. Okay, pumps. Sometimes they have. Some cars they have three pumps. Okay? One in the fuel tank, and then you have another pump near the engine, what they call as low pressure pump. And for the GDI engines, they need to increase the fuel pressure into a very high value, looking at above 20 bar and so forth. So they have another pump, a mechanical pump instead of electronic pump, which they call a high pressure pump. So in total nowadays we're looking at between three pumps, three fuel pumps, two injectors, and also rail, of course. So those are some of the main components of fuel system. So that is pretty much, but please do explore. I don't want to give you everything. Just to using the notes, probably you can just flick through some of the sub components over here, and it's good that you can recognize those components, and also very general functions of those components, so that in the later stage when you want to in the later chapters, in the following chapters, we will definitely use some of the terms used over here. Okay, I think that's pretty much. We've already completed chapter 2.1, which is engine components. Definitely next week we will move on to engine cycles. I don't want to start engine cycles this week, because if I start the engine cycle punya chapter this week, then we will be hanging. So definitely, we will need more time to cover the whole. I will definitely use the whole 2 hours next week just to cover on the engine cycles. But I'm sure most of you are already well aware of the ideal cycles, four-stroke cycles, auto cycles, two-stroke cycles, and so forth. So, but definitely, we need to understand the cycle just before we move on to the chapter 3, whereby we will start doing some of the work related calculating the engine efficiencies and related areas and related calculations lah. Okay, guys. Any questions before I? If you have any questions, you can ask now.
I have one question, sir.
Yeah.
This is basically a curiosity question.
Yeah.
Since that a three-cylinder engine is the worst in vibration, right? But why why is it still manufactured? I'm still wondering why. Because as you can see, the new X50 uses a three-cylinder engine, and that was quite a surprise to me actually.
Think okay, thank you for him. I think on top of the trend, okay, on top of the trend of manufacturers are actually following. Okay, I'll put aside the trend. If you're looking at the three-cylinder, it's more compact, and the amount of components is slightly cheaper to produce. If you're looking at four-cylinder engines and three-cylinder engines, of course, on a four-cylinder engines, you're using much more materials and so forth. And the fact that when they do consider three-cylinder engines, they are much more, I would say, has a better advantage in terms of the size and also the weight. Okay, because when they design engine, they also need to consider other factors as well, such as the weight distribution of the vehicles, the size of the engine bay compartment, and so forth. So there are a lot of consideration nowadays. It's pretty much quite unfair kalau if we totally judge the engine punya selection based on just solely on the engine without considering the whole package of the vehicle. So that is really important as a manufacturer. And the fact that when they produce three-cylinder engines, of course, nowadays, those days, I think, in terms of vibration, yes, that is something that they thought. They thought that they have they have a solution with the counterbalance punya technology. Okay, they thought, but still, yeah, consumers still are still complaining because the vibration from a three-cylinder engine is still obvious especially when you drive the car and so forth. You can see, consumers punya comments and so forth. But of course, nowadays, apart from that, they also need to consider what is the best way for them to produce a higher density engine. So that means a higher density is actually with less amount of engine capacity, you can produce more power. So for example, if you want to produce a 1 liter engine, which produces about roughly looking at probably 150 kilowatt, for example. Okay, 1 liter to produce 150 kilowatt. Do you want to produce a 1 liter based on 4-cylinder engine? Probably, if you consider four cylinder for 1 liter, that will be, the choice is not right. So therefore, based on the 1 liter too, I think because the sizing of a 3-cylinder fits nicely to go for 3-cylinder. Also, they also need to consider when you design engine, 50% of the engine, 50% of the engine, 50% of the subcomponents is on shelf. 50%. So in other words, some of the sensors, piston rings, bearings, and so forth, they are on shelf. You can actually get that from the automotive suppliers, and because of that also, if you want to produce a 1 liter 4-cylinder engine, probably the supplier for the subcomponents, the part is not available. So so it's pretty much quite difficult for them to it's pretty much difficult for them to meet the power density of the engine with a 4-cylinder engine, with a 4-cylinder configuration. But again, the point that I'm trying to tell you is basically to go for a 3-cylinder engine, definitely they have considered many perspectives, not just solely on the engine design itself. They need to consider many perspectives, the whole ecosystem of the vehicle. So they need to consider the vehicle, the chassis, the components, the acceptability of the consumers and so forth. Is that okay for him?
Okay, sir. Got it.
So,
Understand. Okay.
because I think from manufacturer punya, we don't know, because different manufacturer ada different perspective of things. Some would prefer to concentrate on, it depends on manufacturer lah. So some manufacturers, they prefer to go for, they don't like the, for example, they don't like the vibration. So they would either spend money to develop a very good balanced 3-cylinder engine, which requires them time and money to do the R&D, to design a very good counter shaft to absorb the vibration. Or some manufacturers, they might want to consider, okay, let's forget about the vibration, consumers can accept that, let's focus on other things as well. So the different manufacturers are the different preference. So it's unfair to tell, apa yang Proton buat tu silap, apa yang Pro 2 buat tu silap. But I'm sure they have definitely consider, they have their constraints and limitation, and I think they try to make the best of whatever they have. Okay, Fahim?
Okay, sir.
Okay, any more question?
Doctor, do installing turbocharge causes increase in fuel consumption?
Yes, that's a common question. Those days, it depends on which turbocharger you pasang. Kalau you tengok, because there's a method of having the correct size of turbocharger to meet your application. Siapa tanya tadi?
Asik.
Apa nama? Asik. Do you drive a car?
Sekarang mak saya tengah beli ni Altiva. Altiva
Okay.
kan ada turbo charge kan. So saya curious sikit.
Oh, okay. If usually they will definitely okay, turbocharger ni okay. There's two main reason why they want to. Well, the ultimate reason is basically they want to they put in turbocharger is because they want to increase the power output. Okay. That is the main reason. But with the late but the turbocharger needs to be the size of the turbocharger and also the design of the turbocharger needs to be correct, because otherwise it's not just producing power, it's also consuming fuel consumption. Okay, for example, if you have a normal car without a turbo, but you want to have a very powerful engine, then definitely you need to have the correct turbocharger to produce power. But then if you have a turbocharger that's supposed to increase the power at certain condition, engine operation, such as at lower engine RPM and so forth, just to increase the vehicle response, okay, just to increase the engine torque at lower engine speed, that yes, you slightly consume fuel consumption, but on the other hand, you produce much way power output. So the ratio between how much fuel you use and the power that is being produced is the ratio is quite large. So in other words, you are having a higher efficiency lah. So again, this is what the term they use in engineering, which is what they call as turbocharger matching. It is a very common process in turbocharger matching. Turbocharger matching is an engineering approach whereby they select very they analytically select the correct turbocharger so that it fits the purpose of the engine. So if the engine you want to go for racing, for example, in motorsports, we definitely know I want that power at 5,000 between 5,000 RPM to 6,000 RPM. Then definitely we need to choose the correct turbocharger by going through the turbocharger matching process in order so that the turbocharger can actually produce the highest power at 5,000 between 5,000 to 6,000 RPM. But on the other hand, if you want to produce a very responsive car, okay, a very responsive car nowadays, you don't need a big turbocharger. All you need to have the correct size, which is most of the time for a lower speed application. Most of the turbocharger is very relatively quite small, but it's very responsive, very responsive. So you don't need much of the exhaust heat energy to propel the turbine, which is why the turbocharger needs to be small so that it's very light. Okay, and then once the exhaust gas just a very low crude at very low speed, that exhaust energy is able to propel the light weight of the turbine so that it can actually pressurize the air that goes inside the engine. So in other words, you have a very responsive as a result from that you can have a very responsive power at lower engine speed lah. Okay. In terms of fuel consumption, slightly increased, but again, the benefit of the slight increase of fuel consumption, definitely the amount of power being generated is much way higher. So you get more benefit from that. Okay, that's it.
Okay, Doctor. Okay.
So, you know, if Daihatsu did a good job, or sure, I rephrase that question. I rephrase that. If Produa is doing a good job in selecting a good turbocharger, then Produa Ativa would definitely have a benefit on that lah. Slightly increase fuel consumption, but the power is so you don't need to press the accelerator pedal so much. Slightly press the accelerator pedal, then you can have a very responsive engine. That is how I could put that into a layman term lah. That's it. There are cases in vehicles where the turbocharger matching wasn't done properly. Okay, there are cases. So, couldn't can't remember few. But those days, you're looking at vehicles from the 80s and 90s, in the 1980s and 1990s, most of the turbocharger is not meant for fuel consumption. It is meant for horsepower. But looking at the year 2010 and above, Okay, looking at the year 2010 and above, this is when the perception, the usage of turbocharger is no longer for horsepower, but instead for fuel consumption. Hence, probably some of you have already heard about the term of engine downsizing. Okay, engine downsizing is basically they, instead of producing 3-liter engine and A engine, instead of producing 3-liter and A engine, okay, instead of producing 3-liter and A engine, they are now producing a 1.8 liter with a turbocharged that has the same power as the 3-liter and A engine. So that is what they call as engine downsizing. They brought down the engine capacity. Okay, so you don't need so much flow of fuel to combust, but definitely they throw in the turbocharger just to increase the efficiency, and hence you have an equivalent amount of horsepower compared to a 3-liter or 4-liter engine like from the Mustang or something like that. But nowadays, if you look at the Mustang, they want to go with EcoBoost, they are going for 1.6 liter, 1.6 liter nowadays. So everything is going downsizing. But the latest trend nowadays, this year, no, I'm looking at late last year, probably middle of last year, but they are no longer call it engine downsizing. The latest term is engine correct sizing. Nampak tak dia punya agenda dia? So you can flick through what's the difference between engine downsizing and engine correct sizing. Correct sizing is the latest trend nowadays. So that. Okay, any more questions on that?
In terms of, let's say, yang Hasib tadi kan, asked about the fuel consumption in turbocharged vehicles. Is there any, like, I've read somewhere in the internet that if you drive below the RPM where the turbo fully spools, it actually saves more fuel. But at the same time, people are not people are manufacturers are advertising turbocharger as a fuel efficient vehicle, like EcoBoost, you know, the word eco, and CFE, charge fuel efficiency. But at the same time, in CFE, like Proton CFE, they always say like, oh, the fuel consumption is very bad and everything. So why is that? Like why, like in order to save fuel, you don't use the turbocharger, but at the same time you are promoting turbocharging as a fuel economy thing. Is it something like is it, are we driving the car wrong, or we are misinformation macam tu?
Yeah, I think basically, okay, in other words, manufacturer basically sometimes they thought they know what we want. Sometimes they thought they know what we want. So sometimes they if possible, I think if we are all manufacturers, I think we definitely want to produce cars which can cater for everyone lah. Okay, but definitely there are some things that you need to sacrifice in order to get certain benefits. For example, definitely coming back to your question tadi, the time where the turbine starts to spool too, that is actually the time of where does the turbine is fully spooling is by design. So as a manufacturer, you can actually determine when does the spooling starts to when the spooling really starts, either at certain engine speed and so forth. If you drive below the spooling punya region tu, definitely theoretically you are actually driving probably on a natural aspirated punya mode lah. But of course manufacturers, again, they are not perfect. I think some cars, they are actually they are actually designing that turbocharger to operate at certain region, which they thought that the consumers would use it, without considering, most of the time people would go for a lower engine speed. And sometimes when they couple that engine to a transmission, then datang like, and then when the transmission comes into place, then datang lagi cerita lain lagi. So again, of whatever they claim might be not true, and probably what they say from their own punya perspective, they're trying to market the best of whatever they have lah. But from their perspective, definitely they can't actually produce an engine that would benefit in fuel economy and also power output at the same time. Definitely you can't do that. That is something that manufacturer won't tell you, because it's either they would go for a higher output, okay, which can only be achieved at a higher engine speed, okay. That one we will cover that one of why maximum power can only we can only achieve maximum power at a higher engine speed. That is something that we will understand and calculate that later. Why can't we have higher engine power at lower speed? So okay, coming back to the tadi tu, definitely you can't actually have a very good fuel economy engine and at the same time a higher engine output. It's nearly impossible unless the manufacturer willing to spend so much money on getting the engine to have both benefits. But definitely, uh, uh, you cannot serve both at the same time. I'm sure I'm sure some of you probably familiar with the variable turbine on the turbocharger. Even for the variable turbine pun, which is supposed to cater at the lower engine speed and also higher engine speed, also couldn't satisfy the whole engine operation for consumers when you're driving. So it depends. Some consumers, they don't really notice that, but some consumers are really particular on that. Speaking about CFE engines producing more fuel consumption and so forth, there's no doubt there's a high chance, it's not a statement like there's a I'm trying to be careful with the statement. So the, yes, at certain point, people would very be not satisfied with the CFE because it's consumed so much fuel. Yes, but if you look on the bright side, what a CFE engine at that time was actually quite. I would say with the especially on the Proton Exora, I would say I've driven Exora before, so I'm pretty much quite satisfied with the good combination between the engine and also the transmission. But not as, but even much way better than when they have the same engine on the Previa or Suprema. I think the driving experience in the Exora would be the best if you're talking about CFE engines. So yes, they did mistakes and so forth. So if it's consume fuel consumption, yes. I mean, we are consumer. We they from manufacturer from the side of from manufacturer perspective, definitely they will try to market that their engines are the best, best fuel consumption, best highest power ratings and so forth. But again, if it doesn't fit our usage, then we would definitely feel that the engine is not good. Okay, Daniel.
Okay. And last question now.
Hmm.
Yang Atifah tadi, it's actually based on the 1KR punya families of engine, 1KR VET. So my question is like, let's say we have a Beza uses the 1KR VE, but not without the turbo, of course. Is it possible that we can match the optimization in aftermarket, match the optimization of the manufacturers using aftermarket parts when we are installing turbocharged?
So you want to convert like the same engine into turbo, is it?
Yeah, apart from tukar the whole switch the whole engine lah. Let's say we just add the turbo and then focus on optimization.
There's a lot. There's a lot, especially there's a lot. Three main things. I would say three main things. One is basically the compression ratio. So for turbocharge, usually you have a lower compression ratio. We will discuss that one later. But for turbocharged engine, because the fact that it's boosting, so you don't need a very high compression ratio. You need a lower compression ratio because higher compression ratio will actually cause detonation, also pre-ignition for the combustion. So that is one thing, compression ratio. Another thing is basically depends on some turbocharged engines. Turbocharged engines are designed so that the cooling system is very, very, I would say, very aggressive, very, very efficient cooling system. Because on the turbocharged, when you have the combustion is much more aggressive, so you need more cooling on that. So definitely, if you NA engines cooling system is quite simple, straightforward. So when you convert that, when you convert to turbocharge, I'm afraid that probably the cooling is not that enough to extract the heat from the combustion caused by the turbocharger. And of course, the valve timing. So on a turbocharge, you have a different set of airflow that needs to go out. On a turbocharge, the duration of the exhaust valve needs to be much more earlier and also longer because because of the combustion is so high that it produces heat and it requires more opening time for the exhaust valve for the exhaust gas to expel and also allows the heat to escape much more longer period of the exhaust valve when it's open. So those three are the main things that I could think of. I've done it before, but for a long time. So those three are the main critical ones. Then if you don't look into that three main things, it would definitely not work. Your engine might blow or might damage your engine, piston melting, detonations, many sort of damage from that. Does that answer your question, Daniel?
So it's the best that we leave it to the manufacturers.
Yeah, unless okay, there are people that actually took a natural aspirated engine and converted into turbocharged engine. What they did was actually as simple as just lower down the compression ratio, but they haven't thought of like the cooling system, the valve timing, and so forth. Which is why NA engines that actually being converted to turbocharged, they won't last. Second, it won't produce as the same version of the turbocharged design. It would definitely not behave the same if you compare with the conversion ones.
Okay, thank you, Doctor.
Doctor, I have a question.
Yeah, sure.
All right, this is basically about the popular Nissan Almera that is around Malaysia. I noticed that there was introduction of a new one called Nissan Almera 1.0 Turbo.
Yeah.
Okay. I did a little reading about this, and then I discovered that the output power is actually similar to the one of the Almera 1.5.
Okay.
1.5 liter.
Yeah.
is that basically what they call as the fuel efficient is this mentioned? I mean, like instead of an engine 1.5, you put in a 1.0 engine and a turbo, produces similar power output as the 1.5, but at just the fuel consumption is lower than the 1.5.
Yeah, right. I think this is what I mentioned tadi, the engine downsizing punya trend. So instead of producing a 1.5 liter, okay, an engine which produces katakanlah, for example, it's producing 100 kilowatts, for example. So instead of producing a 1.5 liter which produces 100 kilowatt, they can actually achieve the same thing, equivalent, or probably slightly higher, with a lower engine capacity. So with lower engine capacity, definitely 1 liter, we're looking at probably you're downsizing, but you are actually downsizing by 2/3 of the 1.5 to 1 liter. With 1 liter, you're actually consuming less airflow and less fuel compared to 1.5 liter. So siapa tadi tanya? Fahim is it?
Saya
Fahim. Same thing. If you have one bucket of 2 liters, okay, another one you have a bucket of 1 liter of water, for example. If you can manage to compress the 2 liter water into the 1.5 liter, into the 1 liter punya bucket tu, then you have a very the amount of density you are actually you are actually consuming less fuel because the fact that you have a lower capacity, but you're actually producing more power because of the turbocharge. Okay, so this is what they call as engine downsizing lah. I think it's quite common. It's been in the trend for probably 10 to 15 years ago. They start to move down the engine capacity to a lower, but they put in turbocharger to equal, basically to increase the power so that it matches the higher engine capacity lah. That's the whole purpose of turbocharger nowadays. So, but again, you know, definitely when
Another follow-up question as well.
Yeah.
Because of this engine downsizing, is it the reason why they decided to put a 1.0 turbo engine inside the Ativa, which is the engine that is similar to a Beza or an Asia, which is 1.0, which is they just add a turbo and then the power is good enough for an Ativa, which is quite a heavy car to tell you the truth. Is it because of that they are able to put that engine in an Ativa, which is way much more heavier than Asia or Beza?
Yes, I think it's true. Because okay, by right, kalau if you're looking at the whole structure of the Ativa tu, I think probably you're looking at probably 1.3 ton, 1.5 ton, probably much way heavier than Beza lah. So in order to power that, the whole vehicle, they need to understand how much power needs to be generated first. Okay, in order to understand, once they understand how much power is required to move the vehicle, then only they decide. Okay, for example, in order to move this 1.5 ton vehicle, they need to have at least, for example, probably 100 kilowatts of power, probably 200 newton meter, for example, of torque. And then only they decide, okay, let's go for what engine can actually produce this power and also torque. So therefore, probably this is how I would think if I was in Daihatsu or Toyota or Prodwell. So in a way of how to produce those powers. Let's see which engine is available nowadays. So probably they identify, okay, we have that engine in the Beza, but so let's use this engine to let's turbocharge this engine, and basically we can have if we turbocharge this engine, definitely if you can produce this the power and also torque that meets the target to move the vehicle, then that should be ideal lah. What the manufacturers don't want to do is basically to start to design a new engine from scratch, because that will definitely cost time, money, and money is the biggest problem. So they try to avoid to design a new engine totally from scratch or from paper. So probably they can just move on, take advantage of leveraging the existing engine and probably convert that into a turbocharged engine. But I'm sure it's not as simple as just taking the engine and put a turbocharger in it. I'm sure they have considered some of the minor design change, at least in the cylinder head and also the cylinder block, and also I'm sure the piston is different, or probably the compression ratio is different and so forth. So there are details that I don't think it will be the same. Even though like for example, if you take the CFE engine, people might say that the CFE engine, it's actually a Campro, they put a turbo on it, but actually if you look into the cooling channels of the compression ratios, the piston height and everything, the material they use in the crankshaft is totally different from a normal Campro engine.
Kita assignment tu pilih satu tajuk je ke daripada 5 classification.
No, you kena buat 5-5.
Buat 5-5 lah. Okay.
So probably you boleh buat macam mind map ke kat situ ke, or whatever lah, buat using your creativity lah. So but you need to touch on the 5 areas lah. Oh, Ativa 980 kilos same weight as Beza, which is why I think quite amazing.
Yeah, but Asia is around 800, 800 to 850.
Right. Okay. I think among the reason why they want to have the lowest weight as possible is because they want to, which is why they can achieve a very good fuel consumption, I believe. Okay. So, any more questions?
No, dah 10 lah.
Okay, but okay. It's nearly 10 o'clock now. I think some of you might wanna go to sleep or whatsoever. But then, happy holidays to everyone. I'll meet you back next week. Do sign in for your attendance in the chat box too, before you leave. But other than that, we'll see you next week. Just a reminder, those names yang saya mention tadi, Daniel, Farhana, apa lagi saya lupa dah. But you know lah, tadi nama yang mention tadi, 5 names tadi, if you can just share some of the updates on internal combustion engine nowadays, so at least we can share lah. It's more like sharing knowledge lah, the perkembangan semasa. Okay everyone, thank you very much for your time. A good session today. We'll discuss back next week. Other than that, have a very pleasant night and happy holidays. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, doctors.
Thank you, Doctor. Thank you, Doctor.
Doctor, you have meeting